Okay, how's it going, everybody? So you may notice a little bit different video today. I did receive some feedback from a couple of students that the Zoom videos were not the best quality. They were having difficulty seeing some of the lines that were on the paper, is mainly in my geometry class 281. So I decided to go back and do it the old way I used to do it. So I went back to using the YouTube. So hopefully it's a little bit better quality. Please keep giving me feedback. I'm definitely trying to make this as good and easy as possible on you guys as I can, and hopefully this will work. Okay, so as we have done, many times in class before, I'd like to give you something and have you guys just kind of do whatever you remember doing. So here's a chance where you're going to press pause and then do what you think, right? So what I want you to do is I want you to find the greatest common factor for these sets of numbers. Okay, and a quick reminder what a factor is. So reminder, factors are small numbers that multiply to give you a bigger number. Okay, so at least one of your factors would be smaller than whatever numbers that you're trying to do. Sometimes they're both smaller. So anyway, so you're trying to find factors that will multiply, that go into each one of these evenly. Okay, so go ahead and press pause and give that a shot. Okay, so now we're going to take a look at how you might go about doing this. And I think the easiest way to do this is to use what we call divisibility rules. Hopefully you recall something about this when you were going through school yourself, but if not, no big deal, because we're going to go over it right now. But so I'm going to do the divisibility rules here, and I'm going to do them in probably the order that many of you might do them if you were trying to say which ones are the easiest or which ones you remember the best or something like that. So, so if you think about divisibility rule, what we're talking about when we say divisibility rules is what is a description of a number that is divisible by 2, or a description of a number that's divisible by 3 or divisible by 4. So that means that this number here divides evenly into a bigger number. That's what we're trying to find out. So is there some sort of rule that we can remember or some sort of understanding we can remember that will help me find out lots of different numbers that are all divisible by 2, or numbers that are divisible by 6, or numbers divisible by 9, something like that. So 2 is probably the easiest one. I'll bet many of you have some sort of rule, or you can describe what types of numbers are divisible by 2. So we're going to start with 2. So even numbers are divisible by 2. Okay, so even numbers. And how we know if a number is even is that the ones digit is 2, 4, 6, 8, or 0. Okay, so 2, 4, 6, 8, or 0 is the ones digit. That 0 is off the board there. Let's put it down here. So the ones digit is 2, 4, 6, 8, or 0. Or another way you can say it is it ends in an even number. All right, and so an example might be 72. So 72 is going to be divisible by 2 because the ones digit ends in an even number, ends in a 2, 4, 6, 8, or 0. All right, so any number that ends in an even number, that means the whole thing is divisible by 2. All right, okay. The next one you probably can remember or maybe have an idea on is, I would guess, 10. So 10 is any number oh my goodness, I cannot spell the word any. Any number ending in a 0. Okay, so any number ending in 0. Actually, I could move that up a little bit. Should have done that. Okay, so any number ending in 0, like, example, 4, 3, 7, 5, 0. So 43,750 ends in a 0, meaning the last digit is a 0. Therefore, that whole number is divisible by 10. And what you might notice is this number is also going to be divisible by 2. And the reason I know it's divisible by 2 is because it ends in a 0. So more than one number could be divisible by these things. So it's not just, oh, it's 10 and nothing else. So 2 and 10 would go into 43750. Okay? All right. So having said that one, the next one that we might remember, I'm guessing, is perhaps number 5. And the reason I say 5 is because it's very similar to 10. I still can't write the word any. Any number ending in a 5 or 0. Any number ending in a 5 or 0. So the ones digit is either a 5 or a 0. And an example of that might be 3, 4, 6, 2, 5. So 34,652, or excuse me, 25 is, my dyslexia coming out, is divisible by 5. All right, so 34,625 is divisible by 5 because it ends in a 5. So this is the key thing. What I also notice here is that 43,750 is divisible by 10. It's also going to be divisible by 5 because it ends in a 0, and any number that ends in a 0 is also divisible by 5. So what that means is if a number is divisible by 10, then it's going to be divisible by 5 because that ends in a 0 and that's always going to end in a 0. So if a number ends in a 10, then we know for sure, ends in a 0, then we know it's also going to be divisible by 5. Okay, so there's 3, right? So those 3 are probably the ones we remember the best or are most useful to us because we remember them. All even numbers are divisible by 2. Any number that ends in a 0 is divisible by 10. Any number is divisible by 5 ends in a 0. Now, the next ones aren't quite as readily available to us, perhaps. Maybe we don't remember them quite as well. So let me just go to the next one I'll do. I'm going to do the number 3. Okay, so number 3. 3 is the sum of the digits is divisible by 3. Okay, so the sum of the digits is divisible by 3. Let me give you an example. The example would be 432. 432. So if I add these together, right? If I add these digits together, that is 4 plus 3 plus 2, like that. So I add 4 plus 3 plus 2, they equal 9. And 9 is divisible by 3. Since that number that I added 4 plus 3 plus 2 together, since that number is divisible by 3, then 432 is divisible by 3. Okay? So all you have to do is add the sum of these numbers together, the digits, and if that sum is a multiple of 9, or excuse me, a multiple of 3, then it's divisible by 3. Okay, so 9 is. So let me look at this one real quick. I have that one written there. So 3 plus 4 is 7, plus 6 is 13, plus 2 is 15, plus 5 is 20. 20 is not divisible by 3, therefore 34,625 is not divisible by 3. All right? So when I added these digits together, it gave me the sum of 20, and 20 is not divisible by 3, therefore this number is not divisible by 3. Let me take a look at this one down here at the bottom. So 4 plus 3 is 7, plus 7 is 14, plus 5 is 19. So that's a total of 19 down here at the bottom. Therefore, it also is not divisible by 3. So that whole number is not divisible by 3. All right. Okay, so that is our rule for number 3. Okay, so the sum of the digits is divisible by 3, then the whole thing is divisible by 3. Now the next one I'm going to do, I realized I actually did in the wrong color. If you guys know how much I love using color and how much I think it helps us understand. Well, today it's probably no surprise to you that the color actually has some significance here. So I'm going to change this one to a different color. It's not supposed to be red. It's actually supposed to be light blue. And when I tell, whoops, what am I doing? When I tell you why it's light blue, you might see what my color coding means. So it's light blue because the rule for this one is very similar to the rule for 3. For the rule for 3 is you add the digits together, the sum of the digits is divisible by 3, then the whole number is divisible by 3. This one, sum of the digits, just like before, is divisible by, and it's not going to be 3 this time because that was the rule for divisible by 3. For this one, the sum of the digits has to be divisible by 9. And if it is divisible by 9, then the whole number is divisible by 9. So an example of that one would be 4, 3, I keep doing this, 7, 4. Okay, 4, 3, 7, 4. So if I add these together, what I get is 4 plus 3 plus 7 plus 4. Okay, so 4 plus 3 plus 7 plus 4. So 4 plus 3 is 7, plus 7 is 14, plus 4 is 18. And what I notice about 18 is divisible by 9. Therefore, 4,374 is going to be divisible by 9. Okay, so if the sum of the digits is divisible by 9, then the whole number, original number, is going to be divisible by 9. What I also notice is that 1 plus 8 equals 9. Therefore, 3 will also divide into this number. So this number here, 4,374, is divisible by 9 and divisible by 3. And in fact, for all numbers, if a number is divisible by 9, it will always be divisible by 3. Okay, so if 9 works, then 3 works. If 3 works, that doesn't mean that 9 works. It might work, it might not. For example, here, added these numbers together and it equaled 9, right? So that means this number right here, 432, is divisible by 9. But this number, okay, 411, so I add those together and I get 4 plus 1 plus 1 equals 6. So that means 411 is going to be divisible by 3 because 3 goes into 6, but it's not divisible by 9 because 9 does not go into 6. So just because 3 works does not mean 9 works, but if 9 works, I guarantee you 3 works. Okay? So the color coding you might notice here that I said I was putting together is that my brown colors, my dark brown and my light brown, they're kind of the same rules. If you notice what I'm doing on the 10 is I'm looking at the last digit. If the last digit is a 0, then it's divisible by 10. If you look at 5, if the last digit is a 5 or a 0, then it's divisible by 5. So those two rules kind of go together. Then you look at the blue. I got a blue rule here where it's the sum of the digits is divisible by 3. Sum of the digits is divisible by 9. So my blue rules kind of go together. So you also see that I have like a greenish color and a greenish color. I wonder why those might be both kind of green. But we're going to hold those off till last. You see this weird purple one, right? So we got red, we got blue, we got brown, and we got green. Where the heck is purple coming from? Well, what colors make up purple? So the two primary colors that we use to make up purple are both red and blue. So red and blue make purple. And the reason I did that is because if these two rules work, then it's divisible by 6. So if it's divisible by 2 and it's divisible by 3, then it's also divisible by 6. Okay, so we're going to use that one. So that's why it's purple, because purple, the 6 is kind of related to 2 and 3. So that means if it's even, right? So if it's an even number, that gives me the blue part, or excuse me, the red part, and sum of the digits is divisible by 3, then the whole thing is divisible by 3. Okay? So that's what that means. So if it's an even number and the sum of the digits is divisible by 3, then the whole thing is divisible by 6. Okay, so I'm going to give you a couple examples on this one. So here's my first example. I keep using 4 and 3. I have no idea why. I'm going to change that up. Okay, so 153. Is this number going to be divisible by 6? Well, I go back and look at 2 and 3. So 2 says, if it's an even number, is this an even number? No. Then no, it's not. Okay, so I'm just going to write that in red because it's not even. Right? So no. Okay? So this has to be true for both of them. So since it's an odd number, not going to work for 2, so it's not divisible by 6. So let me give you another example. $324. Okay, so here, whoops, not 324. 322 is what I meant to do. So 322. So I'm trying to figure out if this is divisible by 6. So the first thing I do is I check 2. Is it even? Well, yes, it is even. It ends in a 2. The one's digit is a 2, so that's an even number. So that one works. The sum of the digits divisible by 3. So that's 3 plus 2 plus 2, which is 7. No. So then again, it's not divisible by 6. No. Because the sum of the digits don't work for that one. So the last example I'm going to do here. $528. Okay. So for 528, the first thing I do is I check and see, is it even? So it's divisible by 2, and I see the 8 makes it even. Therefore, yes, it's divisible by 2. Then I got to check to see if it's divisible by 3. Well, 2 plus 8 is 10, plus 5 is 15. 15 is divisible by 3, so yes, this is divisible by 6. Okay? So, for 6, we're using a combination of 2 and 3. Both 2 and 3 have to work. If 2 doesn't work, it's not divisible by 6, you can move on. So if it's an odd number, don't even check 6, you're done. Then if it's a 3, it has to be the sum of the digits. So if you add the numbers up and they are divisible by 3, then the whole thing is, and it's even number, then 2 and 3 both work. Therefore, 6 will be your biggest number, or be a factor of it. Okay? Okay, so here we go. Go back in our color coding. So 2 and 3 blend together to make 6. That's why it's purple. 3 and 9 are basically the same rule. That's why they're both blue. 5 and 10 are basically the same rule. That's why they're both brown. Okay, and that leaves me with 4 and 8. So 4 and 8 are both green because they don't blend together because of the same rule, but the rules are very similar. So here's the rule for green. If the last 2 digits are divisible by 4, then that means the whole thing, okay? So if the last two digits are divisible by 4, then the whole number is divisible by 4. So let me do an example for this one. An example, this is one that works. So 3512. So 3,512. All I need to do is look at this part right here. Look at the 12, the last two digits. Is 12 divisible by 4? Yes, 12 is divisible by 4. Therefore, yes, the whole number is divisible by 4. Okay, so let me give you another example. Counter example. Here's an example. Okay, so for this example, let's go 71539. Okay, so now 71,539. Again, the only thing I look at are the last two digits. And the last two digits is 39. Is 39 divisible by 4? No. So then the whole thing is not divisible by 4. Okay? So that's a pretty easy one. You just look at the last two digits. If it's divisible by 4, then the whole thing is. If it's not divisible by 4, then the whole thing is not divisible by 4. And that leads us to the last one here, which is number 8. And number 8, the rule is the last. So here it was the last two digits. And to get 4, that's actually 2 squared, if you can remember, right? 2 squared equals 4. And 2 to the first equals 2. Oops, I'm off the board here. So 2 to the first equals 2. 2 squared equals 4. And that was looking at the last two digits. This one's actually looking at the last digit, right? The last digit's even. So that's kind of interesting. And this one's looking at the last two digits are divisible by 4, right? So the last two digits are divisible by 4. So 8 is actually the last three digits. Divisible by 8. So this is actually 2 cubed. So 2 cubed equals 8. 2 squared equals 4. And 2 to the first equals 2. Here you look at the last digit. Here you look at the last two digits. And here you look at the last three digits. So this red one actually could be kind of greenish. I didn't have a color though that would blend with both of those. So that's why I have that one red. But so these are the key things here. The last three digits are divisible by 8, then the whole thing is divisible by 8. So let me give an example of that. Okay, so 5,240. And so what I do is I look at the last three digits, which are right here. These are my last three digits. Is 240 divisible by 8? And you say, okay, 240, 8 goes into 240. Yes, it does. So yes, that number is divisible by 8. Okay, so here's another counter example. I can't write like this, sorry. Okay, 5,215. So the question is, does 8 go into 215? So I'm trying to figure out 8, something multiplied by 8 gives me 215. If I don't know that off the top of my head, this is what I'm going to divide. I'm going to do that division real quick and see if it works. But I know right now that no, it doesn't. Because there's no number you can multiply by 8 that ends in a 5. So I know it's not going to work. So no, so that means this whole number is not divisible by 8. So what that means is, that number is 5,215. If this is the number, it's still not divisible by 8. If this is the number, it's still not divisible by 8. If I come over here and look at the 5,240, if it's 15,240, that number is still divisible by 4. So all I have to do, or excuse me, by 8. All I have to do is check the last three digits. If they work, then the whole thing is divisible by 8. If they don't work, then the number's not divisible by 8. Okay? All right, so that's your divisibility rules. Oops, sorry, I should be moving here. I'm sorry if I was off the board. I didn't realize that. That's your divisibility rules, and they can help you when you're trying to do the work that we did at the beginning there. So I'm going to slide back and take a look at it and see if we can't do this a little bit more efficiently than perhaps however you did it using these divisibility rules. All right, so here we go. So if I'm looking at the first one here, I have 36, 27, and 72. So first thing I look for is my 2, and I see, is 2 going to work? Well, even, yes. Odd, no. So I can stop because I'm trying to find the biggest number that goes into each of these evenly. So I know 2 is not going to work. So if I know 2 doesn't work, then I know 6 doesn't work. So 6 is not going to work because 6 needs 2 and 3. So those are done. So now I'm going to go to 3 and see if 3 works. So 3 plus 6 is 9. That's good. That works. 2 plus 7 is 9, and 7 plus 2 is 9. Okay, there we go. So I know that 3, I'm just going to write this down real quick here. 3 is going to work for this one, and this one, and this one, because I just did the rule for 3. So now I'm going to check 4. And the last 2 digits, well, I know that 4 does not go into 27, so that's easy. I look at 5, last digit has to be equal 5 or 0. Nope, that doesn't work. I look at 6. Well, I already know 6 doesn't work because 2 didn't work. Remember, for 6 to work, 2 and 3 need to work, so it's not 6. I look at 8. And I know that 8 does not go into 36, so that doesn't work. I look at 9, and I see that 9 goes into 36, so add those together, that's 9. Add those together, that's 9. Add those together, and that's 9. Therefore, 9 works. Okay, so they all add up to numbers that divisible by 9. So then 9 works. And then I look at 10, and I see doesn't end in a 0. Therefore, it doesn't work. So the greatest common factor for this one, greatest means which of these, both of these numbers work. Which one is better? Which one is the greatest? 9 is the greatest. So the GCF for 36, 27, and 72 is 9, because that's the biggest number that divides into all 3 of them. All right, so now I'm gonna take a look at the next one here. And so I see, okay, 644. Well, it's even, right? And even, so 2 works. So I'm gonna check 3, sum of the digits. 6 plus 4 is 10, plus 4 is 14. So that one doesn't work, all right? And then I go, so that means 6 will not work. So then I look at 4 and the last 2 digits, 44, that works. 24, that seems to work, okay? So 4 works, so I can write that down. So I had a 2 a minute ago, that both worked, and then I had a 4. I know 5 is not gonna work because it doesn't end in a 0. And then I should do this here because they're both 2 and 4. And then I go, okay, 6 I know doesn't work. 8, how about 8? So I go 8 goes into 64 correctly, but then I have 4 left over, so it doesn't work. So 8 doesn't work. 9 doesn't work because I already added that one up and it doesn't work. And then 10 doesn't work. So for this one, the GCF is equal to 4 because that's the biggest one that goes into both of them. Okay, so I'm looking for the greatest number that goes evenly into both of those. Real quick, I'm going to mention, notice that we skipped 7. So in our original list, it was 2, 3, 4, 5, 6, 8, 9, 10. And that's because there is no cool rule for 7. 7, we just got to divide out. It's the tricky one. So, okay, so I did figure I better mention that. Okay, so now I go to this one, right? So first thing I look for even. I like it. Then I look for 3. So I'm going to go ahead and do this one in the middle. I have to start the smallest number because there's less things that I have to figure out. So 1 plus 8 is 9. That's good. 4 plus 2 is 6. So that's good. And 3 plus 5 is 8. Plus 4 is 12. So that's good. So that meant 2 worked for each of these. And then 3 worked for each of these. And so what do I know right now then? If 2 work and 3 work, that means 6 works for each of them. Because if 2 and 3 work, then 6 also works. All right. So I check 5. Nope, 5 is not going to work. I check 6. Well, 6 is already there, so I'm already good. I check 8. Well, I know 8 doesn't go into 18, so that doesn't work. I check 9. 1 plus 8 is 9, so that one works. 2 plus 4 is 6, so that one doesn't work, so it's not 9, and it doesn't end in 0, so it can't be 10. So the GCF for this one is going to be 6. Greatest common factor there is 6. All right. Okay, let me move this up a little bit. All right, so now look at this one. And again, I'm going to use my same thing. So what I notice on this one is that they both end in a 5, right? So they both end in a 5, so that's pretty good. So I know that 5 is going to work. That was what I noticed right off the bat. The 2 is not going to work. Let me check 3. So 4 plus 7 is 11, plus 5 is 16. Nope, that didn't work. So that means 3 does not work. Let me check 4. Well, 4 clearly does not go into 75, so that doesn't work. I already did 5. 6 doesn't work because 2 and 3 don't work, so that's not going to work. I look at 8. Well, 8 doesn't go into 40, so that's not going to work. 9, I add these up, and it's not equal a multiple of 9. 10, no, so the answer then has to be 5. Okay? And lastly, these 3. All right, so what I have here is I got 8. Well, that's pretty easy. It's only 2 and 4. So, and then 30 is, so that's a 2, right? So let me go back here. That's 2 and 2 and 2. Those all work. And no 3 here, so then it can't be 6. And then I look at 4. Well, 4, yes. 4, no, so it can't be 4. I look at 5. No 5. Okay, 6 really no doesn't work. I look at 8. 8, yes. 8, no, so it doesn't work. 9, nope, no 9 there. 10, nope, so that means this one, the biggest one is 2. All right, so the biggest number that goes into both 8, 30, and 6 is 2. Okay, so that's how we kind of can get our kids to use and practice using these divisibility rules. The nice thing about divisibility rules is it can cut down a lot of work for them. But kids aren't going to use them unless we require them to use them. So we got to have them do this a lot in class. We got to have them practice it. You got to give homework assignments. Of course, you should evaluate this because then they can do work later a lot faster. So that's what we want to do is we want to get them comfortable with these divisibility rules so then they can start to do some other stuff much, much quicker. Okay? All right, so the last part of our lesson today is prime factorization. Okay, so prime factorization here. And so to do prime factorization, there's a couple of things that you might remember, or at least certainly one thing. And so prime factorization has a way of being written. It's like a format that's being written, which we'll talk about towards the end here. And then the other thing about prime factorization is most of us probably learn this thing called factor trees, okay? So factor trees is where I'm gonna start because that's probably what our go-to is at this point. And then some of us may be familiar with how to do it using upside down division. So if you don't know how to do upside down division or you don't know how to do factor trees, awesome, you're gonna get 2 ways to do it. If you already know one of those, awesome, you're gonna get a second way to do it, all right? There's a third way, but it just takes a lot more time, and I'm probably not going to spend too much time on it because these are a little bit more efficient. Okay, so for factor trees, what I'm going to do, what I get to do is I'm going to break it up into factors that I know. And that's what's nice about factor trees is they get to start with numbers that they know, multiply to give me 90. Okay, so most kids looking at this number, most people might go, well, that is 9 times 10. Okay, so now I can stop the second I get to what's called a prime number. We didn't talk about prime numbers yet. We're going to talk about that today. So prime numbers, right? So prime numbers are numbers that have exactly 2 factors, 1 and the number. So are there only 2 numbers I can multiply to give me 9? Or is there more than 2 numbers? Is there only 2 numbers I can multiply to give me 10? Or are there more than 2 numbers? So most kids look at 10, they go, well, you can multiply 2 times 5. So that's exactly 2. So yeah, you're done, right? Well, I agree. 2 times 5 equals 10, but so does 1 times 10. So 1 times 10 are also factors of 10. So I got to keep going until these numbers only have 1 and themselves as a factor. So I got to keep going on this one. So what these numbers are called, if they're not prime, the other word that we have for these numbers is composite, okay? Composite numbers have more than 2 factors, okay? More than 2 factors are what composite numbers are. We're going to deal with prime numbers for this part of it, and prime numbers are extremely useful. You all love prime numbers, especially if you've been locked up for any amount of time because of this coronavirus. You love prime numbers. I can tell you why. Okay, so what numbers multiply to give me 9? Well, I know that 3 times 3 does. All right, perfect. What numbers multiply to give me 10? 2 times 5. Now what I'm not going to do here is 1 times 9 and 1 times 10, because that doesn't break this down any further. I'm trying to break these down into prime numbers, and once I get them into prime numbers, then I get to stop. So what I see here is I have 3 times 3, and both of these are prime numbers because 1 times 3 equals 3. That's it. 2 times 5, 1 times 2 equals 2, 1 times 5 equals 5. So now I have all these in prime numbers. So that means my prime factorization, my PF, my prime factorization is going to be 2, and you usually write it in ascending order, so the smallest factor to the largest factor. So 2 times 3 times 3 times 5, right? So 2 times 3 times 3 times 5. So I did 2 times 3 times 3 times 5, all my factors. But then we want to write that in shorthand. So we're going to write with exponents. So it'd be 2 times 3 squared times 5. Okay, now you may recall back when we were doing multiplication that I really don't like that symbol for multiplication. I think at that time I even mentioned there's really only a couple of times in mathematics that I think this symbol should be used. Guess what today is? Today is one of those days I think it should be used. It's a little bit cleaner than trying to use the X or the parentheses. So even I like to use the dot when we're doing prime factorizations. So 2 times 3 squared times 5. Okay? So now I'm going to do the same problem, but this time I'm going to do what's called upside down division. And so in doing upside down division, this is going to look similar to some of you. You may remember doing this a couple of weeks ago. But I'm going to draw something like this that looks like an upside down division sign. Okay? So before, when we were doing this, it was when we were trying to find converting bases, right? That's when we were leaving base 10, we did this. So here, I don't know what number goes on the outside. Before I knew what base I was going into, now I just got to figure it out myself. So the only thing about this number out here is that number that you put on the wall of this little house thing has to be a prime number, meaning I can't do this. I can't put a 10 there because this number has to be prime. So what a lot of kids do is they start with the divisibility rules and they just go with the smallest number that they know that goes into there. And a lot of times it's a prime number. So if I look at 2, does 2 go in here? It sure does. 2 goes into 90 2 times, right? So 2 times what gives me 90, all right? So that works. But other times a kid might go, well, 3 is also prime, and I know 3 goes into 90. That also works, okay? I don't care. Whichever the ones they want to do. If they go, you know what? I don't really know how many times 2 goes into 90, but I know this number needs to be a prime number, and 3 goes into 90, great. If they say, you know what? It ends in a 0, and I know 5 is a prime number, so 5 will go in there. Fantastic. I don't care what number they use outside here, as long as it divides into this number evenly and it's a prime number. So I'm going to stop with 3 there. So 3 goes into 90 30 times. All right, 3 times 30 equals 90. Now, when this is a prime number here, I get to stop. If it's